Okay, Hannah, here's the problem that your dad gave me, and let's get started. So the first thing you want to do is you want to take the first term and the last term, and you want to multiply them when you factor by grouping. And so 2 times -1 is -2. And why do we do that? Because we're going to split this middle term here, -x squared. We're going to split it into 2 terms so that it still equals -x squared. In other words, we're going to make this from 3 terms to 4 terms. So what's the coefficient here? What's -1? So I'm going to go ahead and split this so that when I add them, I get -1. Well, -2 and +1, when I multiply them, give me -2, and when I add them, give me -1. So these are how I'm going to split that middle variable. Okay, let me just, so I'm going to rewrite this, and I'm going to rewrite it as 2x to the 4th. And actually, let me put the original one up so you can still see it. So this is what I had. And this is what I now have. So the 2x to the 4th is unchanged, and this becomes -2x squared plus x squared. Notice together they still add up to -x squared. And then -1. The first and last term you just copy, and this middle term you just split into 2 terms. Okay, well, why do we do that? Because this is where we're going to factor by grouping. We're going to take the first 2, and we're going to pull out a common factor, and we're going to take the last 2, and we're going to pull out a common factor. So what's the common factor of this first one? 2x squared. So I'm going to pull out a 2x squared, and I'm left with x squared minus 1. Remember, pulling out a common factor, greatest common factor, means you're just dividing the first and the second term by what you have on the outside. Now over here, there is no greatest common factor. It's just 1. So I'm going to actually just pull out a 1. You still need to pull out something. You know you did it correctly when your binomials, or what's in the parentheses, both times are exactly the same. If they're not exactly the same, you did something wrong. So now we're pretty much done. Your final answer is you take the outside terms, you take the outside terms, this, and they become one binomial. So 2x squared plus 1. And then you take the repeating one, which is right here, and you only write it once. You know, I mean, even though it appears twice here, you only write it once in the problem. X squared minus 1. Now, you're done factoring, factor by grouping, but if you've, and I'm not sure if you've covered this, if you covered difference between 2 squares, then there's more to do, and I'll show you. If you haven't covered difference between 2 squares in your class, then ignore what I'm about to do. Difference between 2 squares, this is difference between 2 squares, meaning this is still factorable. So this first one is just 2x squared plus 1. That hasn't changed. And difference between 2 squares means it's basically the square root of x squared is x and x. The square root of 1 is 1, and 1 has a minus, and 1 has a plus sign. And that's the first problem. So this is the complete answer to that first problem. Unless you haven't discussed difference between 2 squares, then that's your first answer. Okay, let's go. Let me check and see the next problem that your dad texted me. Let me see. 4x to the 4th. Here we go. So 4x to the 4th plus 3x squared minus 1. Okay, same thing. I'm going to take the first and last term here, and I'm going to multiply them, and I get -4. And then I'm going to split +3 using factors of -4. Well, +4 and -1 are factors of -4, and they also add up to +3. So that's what I'm going to use. So this, basically I'm going to split the 3x squared to 4x squared and -1x squared. So I'm going to go ahead and rewrite it. So it's 4 x to the fourth, so that first term doesn't change, to 4x squared minus 1x squared. You really don't have to put the 1, as you know, and then minus 1. All right, and just like the last time, we're going to go ahead and group these, the first two together. And you don't always have to do the first. Sometimes the first two and the last two don't always work out. You've got to kind of rearrange the order a little bit. But so far, we haven't had to do that. So let's pull out the greatest common factor of the first one. And the greatest common factor of this first one is 4x squared. And I'm left with x squared plus 1. And here, there is no common factor, but I'm not going to pull out a 1. Remember, they have to be, the binomial I have here and this one, they have to be the same. So if I pull out a negative 1 as my greatest common factor, that will make the x squared, negative x squared, positive x squared. So it's like this one. It's like this one. And that will make this negative 1 positive 1. Whoops. So it's like this one. So now they're exactly alike. Okay, so let's go ahead and assemble them. So now I have 4x squared minus 1, so that's one binomial, and x squared plus 1. And again, if you haven't discussed the difference between two squares at home, then at school, then you're done. Otherwise, this is different. You can use difference between two squares because 4x squared is a perfect square and 1 is a perfect square, and they're being subtracted. So the final answer is, let's see, square root of 4x squared is 2x. 1 goes here and 1 goes here. The square root of negative 1, or the square root rather of 1 is 1. So 1 goes here and 1 goes here. 1 has a plus and 1 has a minus. And then the x squared plus 1, that is not factorable. And you're done. I hope this helps. Good luck. Bye-bye.